The first part of this chapter is really getting the idea of what we mean by internal energy. The study of thermodynamics is all about how energy is transferred, usually through heat, hence thermal dynamics, but it's really all about telling us what the structure of material is like and how the material behaves. So most of the stuff we call that we're going to study is called simple materials, which effectively is a gas. Because the gas, when you change it down in temperature, can go into different phases. So we can have vapors, we can have obviously liquids, we can have gases and solids, and if we go up to the other end, then we go into ionized gases or plasmas. So at the basic level, we know what solids look like, but it doesn't mean that solids all behave the same. So for example, this and this, they're both behaving in the same way. They can both have energy, they can both vibrate, we can do stuff with it, the structure can change and so on. That behaviour all depends on the particles themselves, the movement of those. So for example, they're all vibrating now because I've hit them, or these, which are much more obviously vibrating. But it's the behaviour of those particles, the energy they've got, but also the energy in the bonds as well. So the bonding, whether it's ionic, covalent, giant covalent, metallic, etc., etc., it doesn't matter what the bonding is. The behaviour per se all depends on those two things. And how we change that behaviour, how we change the behaviour of the bonds held within the bonds, the forces, which of course give it energy, because you moving against those forces or with those forces is doing work. But if we change that energy, then we change the bonds, or we change the movement of the particles themselves. And again, those can move in different ways. They can rotate. Obviously they can't on this, but in real life they can rotate, they vibrate, and they also translate, they move. So there's three types of kinetic energy. They can do three kinds of motion. So these two solids nominally are the same structure, but this one, because it takes a lot more pushing than this one, this has much more energy within its bonds itself. So the potential energy is bigger because these forces are bigger, whereas this is quite weakly held, so it wouldn't take much energy to release the energy from these bonds. In fact, there's one that's broken already. So this is already on its way, these particles are already on their way to becoming liquid particles. Okay, and the difference between those different states, different phases of matter, solid to liquid to vapor to gas to plasma, is all about increasing the overall energy, the internal energy of the substance. Okay, so it's not just individual particles. When we're looking at the whole structure of things, the internal energy of a material, of an object, it's everything in it. Okay, which at a simple level, bonds, particles, stuff that you mentioned at GCSE, but we're going to go into much more depth.